Hello everybody, welcome to another episode of BioStar Health. Today we are going to discuss two major objectives. One is how to generate mean and standard deviation in Excel, and after that we are going to explain why we should know mean and how always mean should be explained or presented with standard deviation. What is the importance of presenting mean with the standard deviation? First of all, let us see how you can prepare a mean and standard deviation in Excel. This is a data regarding systolic blood pressure for two groups. One is for group 1 and group 2. So here I am going to just calculate first the mean value of it. Select one column, box, and place equal. Equal is always give us the function aspect. Then you put an equal and write AVR. You will get average. Just double click on the average. Then they will ask us to select some number for which you want to get average. Select all those numbers, 20 numbers, and just enter. So you have the average, which is 120. Now our next task is how you determine standard deviation. Just click on one box and place equals. Then you type STDEV. There will be two options. One is stdv.p, which is called population, and another option will be stdve for S. Please click on or highlight S and click on it. Then they will ask us which are the numbers. Then you go up. We want to calculate the standard deviation for that particular mean. Then select all those 20 numbers and click enter. Now you see there is 120 is the average for all this group data of 20 members, and 12.55 is the standard deviation. Now what is mean and what is standard deviation, which is our second part. We'll go back to our slide. Why mean and why standard deviation? This is a data pertaining to 16 members, 20 members of I have collected just a sample data for 20 members where I collected the systolic blood pressure. The first person's was 110 millimeter of mercury, second was 115. Then like that I collected all the 16 persons, 20 persons number, and I calculated the average of this or the mean of this by adding all the equal values, all the 110, 120, 125, 115 each value, and divided it by 20. You will get a mean value of 120.5. Up to that part will be clear for you. This is how you calculate the mean or average. So the mean is represented for a sample. It is represented as X bar. Like this, if you just look into this, this is what is called as the X bar, and this is read as X bar, and the value is 120.5. So very easy. Mean is the measure of the central tendency, which is give us the central value of this. It is an average of the set of values. For population, for the large population, mean is being presented as mu or written as this, and sample, for a sample, mean is written as X bar, which I just told you, which is the most widely used and dependent on the value of every observation. As I told, for the calculation of mean, we are taking x1 plus x2 plus x3 up to x raised to n divided by n. So we are including all the values, mostly widely used and dependent on the value of every observation. And it is a balancing point of a distribution. When you look into a distribution is like a distribution. Mean is always as a balancing point of a distribution. We will have another episode of what is distribution and what are the different types of. For a normal distribution, mean is the balancer. So especially this distribution is like a normal distribution. So it is not appropriate for quality data. If you have just please have an opportunity, just look into our BioStar's types of data. As I told, there are two types of data, qualitative and quantitative data. So mean is usually taken for quantitative type or continuous type of data, where the distribution is normal distribution of all those data values. And the most important thing is the mean is sensitive to extreme value. Suppose there are three things, one is 3, another value is 4, and again the third person's value is again 3. So 3 plus 4 plus 3, you will get somewhere around 10, and if I divide it by 3, you will get around 3.3. Suppose one value was extreme here. If I just replace this value with 10, so you can see that even though you are getting the same value, 3 plus 4, 17 will be divided by 3, and like the average 3.5 will again shift to 6 points. So even if there is an extreme value is there, so mean is always going to affect. That's why I told mean is not common as far as skewed distribution is concerned. Mean is usually presented along with the normal distribution or the binomial distribution pattern values. So usually mean is expressed along with standard deviation, but why? Now the question is, why mean is expressed along with standard deviation? In order to look into that, to answer that, we'll just look into or we'll continue our day presentation. Now I have seen this is our first information. We have taken the value of this 20% and the mean value was mean x bar was 120 point. Similarly, I collected another group, one population and another population, which we'll call as group 2 population. So this is group 1. So I collected the information. Then I was looking into each of this value. There are almost 20 persons are there, same number of persons, and the mean is again 120.5. So mean of the first group 1 and mean of the group 2 is 120 points. But when you closely look into the data points, we can see that only few persons, that is those with green, are considered as normal, which is normal is 120 mm of systolic blood pressure. All the other groups, majority of them either go to the lower blood pressure gang or into they are a high or hypertensive blood pressure groups. Why this? Even though the mean appears to be normal, because when you look into each of these values, that shows that this mean generation has been which is equal to 120.5, which is due to a lot of lower values and a lot of extreme hyper. So this is a group with a more hypertensive and hypotensive group. So when you look into this, we can say that usually whenever we are going to do studies, we are going to compare whether one population is and their values is similar to another population and their values. Even though if you just look into this mean value alone, which is equal to 120.5 and 100 for group 1 and group 2, we can say that the population or the group is similar. But when you closely look into that population characteristics, we can say that even though the mean of both the group is there, but one group is having more hypertensive and hypotensive subjects rather than normotensive patients as far as group 1 when you compare with the group 2. So what is the moral of this is that with mean alone, you cannot judge whether two group is similar or not. So we need to have another component which is always exhibited along with this. We need to calculate the average deviation of each value from mean for the entire sample population. This is what is called as the. So when I just plot the average deviation of this, we can see that this blue line is almost at this level it is going. For the group 2, the deviation is more, but the mean is same. So we need to have some point or some measure that calculate what is the average deviation of this. So mean with that average deviation, and when you compare with group 1 and group 2, we can say that whether that population is similar or not. So this average deviation is what is called as the standard deviation. So what is standard deviation? Standard deviation measures the variability among the individual values within a group. It is a description of the average distance of the individual observation from the group mean. Standard deviation is reported always along with the sample mean. usually in the format mean plus or minus standard deviation. So how you calculate standard deviation? Standard deviation is calculated by each value minus x bar. X bar is our standard deviation. It shows you. So if the first value is 110, you minus it with the 120, you will get a value called as 10. Then you square that value. So x bar, xi minus x bar the whole square divided by n minus 1. So that value, that square root of this value is called a standard deviation. So what is standard deviation? Standard deviation measures the variability among the individuals. We need to get the standard deviation, or we need to calculate the standard deviation, and that has to be exhibited along with the mean always. So hope you understand what is the importance of mean and standard deviation. So try to learn this and try to utilize this form. But in Excel it is very easy to calculate. You can use that video, early video, and say, and you can easily calculate mean and standard deviation. Thank you once again for spending time with us. If you have any special queries or comments, please write on our comment boxes. Thank you very much.